Hello, dear students. Welcome to our online class. In this lesson, you will learn how the study of electromagnetic waves came to be. It is here that you will find out who were the proponents on the formulation of the electromagnetic theory. Furthermore, this lesson will enable you to gain more information about the scientists who made great contributions to the development of this theory. Come on, let us explore. The first scientist is James Clerk Maxwell. James Clerk Maxwell is an English scientist who developed a scientific theory to better explain electromagnetic waves. When Maxwell used this field theory to assume that light was an electromagnetic wave and then correctly deduced the finite velocity of light, it was a powerful logical argument for the existence of electromagnetic force field. He noticed that electrical fields and magnetic fields can couple together to form electromagnetic waves. Maxwell discovered that a changing magnetic field will induce a changing electric field and vice versa. An electromagnetic wave exists when the changing magnetic field causes a changing electric field, which then causes another changing magnetic field, and so on forever. So the electromagnetic wave may forever. And take note, unlike a static field, a wave cannot exist unless it is moving. Once created, an electromagnetic wave will continue on forever unless it is absorbed by matter. The second scientist is Heinrich Hertz, a German physicist who applied Maxwell's theories to the production and reception of the radio waves. And did you know that the unit of frequency of radio wave, 1 cycle per second, is named after him in honor of Heinrich Hertz? He proved that the existence of radio waves in the late 1880s. He used two rods that serve as the receiver and a spark gap as the receiving antennae. Where the waves were picked up, a corresponding spark would jump. Hertz showed in his experiments that these signals possessed all of the properties of electromagnetic waves. With this oscillator, Hertz solved two problems. First, timing Maxwell's waves. He had demonstrated in the concrete what Maxwell had only theorized, that the velocity of radio waves was equal to the velocity of light. This proved that radio waves were a form of light. Second, Hertz found out how to make the electric and magnetic fields detach themselves from wires and go free as Maxwell waves. The third prominent is Michael Faraday. Michael Faraday is probably best known for his discovery of electromagnetic induction. His contributions to electrical engineering and electrochemistry are due to the fact that he was responsible for introducing the concept of field in physics to describe electromagnetic interaction are enough for him to be highly recognized. But perhaps it is not so well known that he also made fundamental contributions to the electromagnetic theory of light. In 1845, just 176 years ago, if I am not mistaken, Faraday discovered that a magnetic field influenced polarized light. It is a phenomenon known as the magneto-optical effect or the Faraday effect. To be precise, he found that the plane of vibration of a beam of light, linearly polarized light incident on a piece of glass, rotated when a magnetic field was applied in the direction of the propagation of the beam. This was one of the first indications that electromagnetism and light was related. The following year, in May 1846, Faraday published an article named Thoughts on Ray Vibrations, a prophetic publication in which he speculated that light could be a vibration of the electric and magnetic lines of force. So this is the another scientist named Andre Marie Ampere. Andre Marie Ampere made the revolutionary discovery that a wire carrying electric current can attract or repel another wire next to it that's also carrying electric current. The attraction is magnetic, but no magnets are necessary for the effect to be seen. He went on the formulation of the Ampere's law of electromagnetism and produced the best definition of electric current during his time. Ampere showed that two parallel wires carrying electric currents repel or attract each other depending on whether the currents flow in the same or opposite directions, respectively. He also applied mathematics in generalizing physical laws from these experimental results. Most important was the principle that came to be called Ampere's law, which states that the mutual action of two lengths of current carrying wire is proportional to their lengths and to the intensities of their currents. Kaya pa ba? So ito na yung huling scientist. The last one is Hans Christian Ørsted. Is a Danish physicist and chemist who discovered that the electric current in a wire can deflect a magnetized compass needle, a phenomenon that the importance of which was rapidly recognized and which inspired the development of electromagnetic theory. In 1806, Ørsted became a professor at the University of Copenhagen, where his physical researches dealt with electric currents and acoustics. During an evening lecture in April 1820, Ørsted discovered that a magnetic needle aligns itself perpendicularly to a current-carrying wire, definite experimental evidence of the relationship between electricity and magnetism. Is there any questions or clarifications? No. So, if you have one, you may message me on the following contact details you are seeing on your screen. So that's all for today. Keep safe and God bless. Thank you very much for listening.